Hello class. Today we are looking at section 5.5, factoring the sum and difference of two cubes. Now when I hear the word cube, what does cube mean? Cube means 3. Just like when I hear square, it means 2. So when we hear cube, we want to think of 3. On page 338, it says factoring the sum of two cubes. So please read over that. And on page 339, you have the factoring the difference of two cubes. So please look over that. The main thing I want you to pay attention to is the sign rules. Now turn to page 341 and look at number 23. It says factor. 23, I have a to the third power plus 8. This is a binomial. The leading coefficient is 1, the degree is 3, and my constant is 8. I can take the cube root of a to the third and 8. So I'm going to do a little side work to show you that. We have the cube root of a to the third. In my index, I do write the 3 to indicate it's a cube root and not a square root. The 3's will cancel. I am left with a. So the cube root of a to the third is a. Let's look at 8. If I break down 8, 2 times 4 is 8. 2 times 2 is 4. If you notice, I see 2 3 times. For the cube root of 8, I'm going to rewrite it as 2 to the third power because I see 1, 2, 3 2's. The 3's will cancel and I'm left with 2. So the cube root of 8, which is equivalent to 2 to the third, the cube root of 8 is 2. Those are important that I want you to remember. Those are two important things. When I'm doing a cube root, we want to break down the first term and that second term. Cube root of a to the third is a. Cube root of 8 was 2. I'm going to erase that part. And we're going to now factor. But we want to keep that in mind. You have a sign order when it's a sum of two cubes. When we talk about the sum and difference of two cubes, we're going to see binomials. Just like when we say perfect square, or the difference of two squares, we're going to say binomial. So very important that you pay attention to when do I do a perfect square and when do I do a sum and difference of two cubes. If I can take the square root, we want to think about a perfect square. If I can take the cube root, I want to think about sum and difference of two cubes. On a perfect square, my exponents can be even numbers, 2, 4, 6, 8, 10. Perfect squares, I'll see those types of exponents. When I'm talking about the sum or difference of two cubes, my exponents are multiples of 3. It can be 3, 6, 9, 12, 15, 18. So that's a way to kind of start off to see which method am I going to use. So when we think about binomials, think about, you want to always start off with, does it have a GCF? Start with GCF every single time. After GCF, think of perfect squares, sum or difference of two cubes. Those are the methods you want to think about when you see binomials. The sign order for plus is plus, minus, plus. Every single time it's going to be plus, minus, plus. Every time. So you need to write down what I'm saying so you'll have these notes. The first thing you need to write down is I want to take the cube root of a to the third, which we know is a. So you want to write, take the cube root of a to the third. In the second space, you want to write down, take the cube root of 8. The cube root of 8 is 2. Take the cube root of 8, which is 2. Okay, so now, the next step is I'm going to square the a. So when I say square the a, I'm saying what is a times a? A to the second. I'm going to jump here. I'm going to square the 2. So 2 times 2 is 4. So square the 2 is what you need to write. For the middle part, I'm going to multiply the 2 and the a. So 2 times a is 2a. A. And that's it. It's that easy. So what you need to write again, let's talk about that. Take the cube root of a to the third. Take the cube root of 8. Square the a. Square the 2. Multiply 2 and a. And that's what you will do every single time. And you'll get the right answer. But you may say, well, why is it plus minus plus? The only way I can explain that is to check your work to see what happens. I see a 2 by 3, so I'm going to use the box method to check, which is nothing but, it's just a different way of doing distributive property. I just have a visual. And we've done this in our previous notes. I have a plus 2. I have a squared minus 2a plus 4. All right, now do your math. A times a squared is a to the third. Remember your rule, when multiply to add the exponents. That's what I'm doing. A times negative 2a is negative 2a squared. A times 4 is positive 4a. 2 times a squared is positive 2a squared. 2 times negative 2a is negative 4a. 2 times 4 is positive 8. Tell me what you notice. What do you notice? Well, I notice that 2a squared minus 2a equals 0. 4a minus 4 is 0. And the only thing that's left is a to the third plus 8, which is my original problem. So you must write your sign order when you're doing a sum as plus minus plus, so that when you check your math, it's still going to be the original expression. Very important. Let's try another one. Number 25. We have 125 x to the third plus 8. Right here, I need to find one number. I can multiply 3 times to get 125. And if you said 25, that's wrong. Do a factor tree to check yourself. I know that 25 times 5 is 125. And then I know that 5 times 5 is 25. So I see 5 3 times. So the cube root of 125 is 5. And we already found the cube root of x to the third. It's just x. And then the cube root of 8 is 2 again. We found that already. So I want to do a little parentheses and a big parentheses. And my order for sum is plus, minus, plus. I take the cube root of 125 is 5. Cube root of x to the third is x. Cube root of 8 is 2. Square the x to the x, 5x, square that. 5x times 5x is 25x squared. Square the 2. 2 times 2 is 4. Multiply these two. 10x. And that is my final answer. And then, of course, you can check it again, and we've already talked about that to make sure your answer is correct. Now, let's do one with a sign of subtraction. Let's look at number 45. I have 27, a to the third minus b to the third. Little parentheses, big parentheses. My sign order for the difference is minus, plus, plus. So the only thing that changes is that sign, those signs, but we still do the same procedure. The cube root of 27. Think of those three numbers. Okay, so I have 9 times 3, 3 times 3. So the number that I'm going to see 3 times is 3. So the cube root of 27 is 3. I have 3 The cube root of a to the third is a. Cube root of b to the third is just b. Square the 3a. 3a times 3a is 9a squared. B times b is b squared. 3a times b is 3ab. And that is my answer. And of course, you can do the Schroeder property or the box method and make sure your answer is correct. Number 47. I have 2x to the third plus 54. You have to ask yourself, what do they both have in common? They both have a 2 in common. And the reason I said that is because, can I take the cube root of 2? Can I find one number, multiply it 3 times and get 2? It's nothing out there that I can use that I can multiply 3 times and get 2 again. And I'm looking for whole numbers when I'm saying that statement. I want to find 3 whole numbers that I can multiply. I want to find the same whole number I can multiply 3 times get 2. There's nothing out there. So when you can't use the strategy, go back to GCF. My GCF for the 2 is 2. We're going up and down, so we divide. 2 goes into 2. X to the third times. 2 going to 54 27 times. Now, I can take the cube root of x to the third and 27, so we can go ahead and work this all the way out. My sign order for addition now is plus minus plus again. Cube root of x to the third is x. Cube root of 27 is 3. 3 times 3 is 9. 9 times 3, 27. When you multiply 2 numbers at a time. 3 times 3, 9. 9 times 3, 27. Always do that. Square the x. X squared. Square the 3. 9. Multiply the 2. 3x. And that's my answer. If you knows with the 2, just keep bringing it down. Don't bother it anymore. Number 49. We have negative x to the third plus 216. What did I say when your leading coefficient is negative? What do? You factor it out. When you're factoring, don't factor in that negative sign. Get it out the way. So we're going to factor out that negative. So we know a negative divided by a negative is a positive. A positive divided by a negative is a negative. And then do a quick check. Negative times positive, negative, negative times negative, positive. Do a quick check to make sure you did it right. Now, when you look at the new information, it is a difference of 2 cubes. So bring down the negative sign. Little parentheses, big parentheses. My sign order for subtraction is minus, plus, plus. Cube root of x to the third is x. Cube root of 216 is 6. 6 times 6 is 36, and 36 times 6 is 216. So these are pretty easy to kind of figure out. Just think about it for a minute. Use your calculator to verify that you picked the right number. It should be 6. Square the x. Square the 6. And when I say squared, I'm saying x times x. I'm saying 6 times 6. Combine, multiply these two terms together. So 6 times x is 6x. And that is all you do with number 49. Very easy. Try 51 and then check your answer in the back of the book. That's a real good one. You do have to find a GCF, but make sure you're looking at the number and the variables and you factor all of that information out. And then go ahead and try it again and see can you figure it out. That's a very good one to try. Try that one. So for chapter 5, this is all we're going to do as far as our factoring methods. So let's talk about what methods we have used. I do want to stress that We will not look at section 5.6 online because it is a summary of everything we've done already. So I'm not going to do notes for 5.6 because we have them in all the other sections. So go to 5.6, look at those problems and see what strategy would you use to get those correct answers. So take 5.6 as an opportunity to review on your own. 7.4 is also a review of factoring too. So on that one, I will not be doing online notes for that. I will go ahead and do notes on section 5.7. So very important that you look at those notes too. Because on 5.7, we are still doing an overview of everything we've talked about, but now we're solving for x. So it's very, very important that you know how to get x by itself. That is so important. Now, the methods we have talked about so far, let's write those down so we'll know. We have talked about finding the greatest common factor. We have talked about factor by grouping. And when I see grouping, I'm going to look at 4 or 6 terms. We talked about difference of 2 squares. Another name for that, and it's an old school name, perfect square. And when we see perfect squares, we want to think about the conjugate. We also talked about factoring trinomials when the leading coefficient is positive 1. We talked about the master product method. So we talked about trinomials when the leading coefficient is not positive 1. And on that, we're going to start talking about them. And with that, we talked about the master product method. Okay. Also, we talked about difference or, well, not or, I'm not going to say the word or. The difference, and we talked about the sum of 2 cubes. And one more I want to add, we also talked about perfect trinomials. Okay, so make sure you can see all of those. We talked about greatest common factor, grouping when I see 4 or 6 terms. We talked about difference of 2 squares, perfect squares, and we know we need to think about the vocabulary term conjugate. We talked about trinomials when the leading coefficient is positive 1. We talked about trinomials when the leading coefficient is not positive 1. And that's when we applied that master product method. In the book, they do a trial and error technique. So you can also use that method as well if that's how you was taught before. And we also talked about the difference and sum of 2 cubes. And we talked about perfect trinomials. And I do want to stress that when you talk about the difference of 2 cubes, you'll talk about binomials. You see binomials. When you talk about a perfect trinomial, it's a trinomial, of course. Difference and sum of 2 cubes, you see binomials. But when we do GCF, it can be any type of polynomial when you're talking GCF. So before you go into all of these strategies, start with, does it have a greatest common factor? Once you identify that, then you look at these other methods. So make sure you study that, and you also can go online, look at a lot of online notes. They have so many different ways you can work with trinomials. So if you don't like the master product method, they have other strategies out there that you can look at. So study that. And then also relate to me. Let me know if you don't like the master product method. I can go over another strategy. I do a strategy called bottoms up method. It's longer and it's structured, but that's another way you can look at that. So if you don't like master product method, let me know. But you can look it up very easily and see that for yourself. Okay, so We are going to go on to section 5.7, but for now, that is it as far as our different strategies that we're going to look at with factoring. So it is so important that you understand these methods and continue to study. Any concerns, let me know.